The minus one means I add one more. So everybody look up, please. Here's how we do it. Go 1, 2, 3, 4, 5, 6. I filled in from the bottom up. 7, 8. What rule is that? Hund's rule. You gotta know the rules that apply here. That's Hund's rule. I go 7, 8, 9, 10, 11, 12, 13. That's a pretty diagram, if I say so myself.
Shut up.
What's up?
When you're filling in the pi 2p and the pi section, we go
1, 2, 1, 2. They're the same energy. They're the same energy. It's okay. They're the same energy. All good. All right. So that's why I say same energy equals. So they're the same energy right there. All right. So now we can find the bond order. BO. Right. Somebody smells. Now the bonding is going to be 2, 2, 2, 2. So that's 8. Minus the anti-bonding, which is 2, 2, 1. So that's 5. So that's 3 halves. Agreed? That's how you find it. So bond order is a little bit different in that case. All right. Now we're gonna do. Let's do the next one here. O2. All right. It's the same one, so I just draw the same fucking thing. I don't have to rewrite the whole thing again. I just be like, I drew that. Okay. I know that these are the stars. These are the stars. These are the stars. I don't care what the labeling is because I already did it here. So that's the same one, right? Because they're still what? They're using the same diagram, right? Because they're all oxygen, so they have the same exact diagram. So for O2, it's going to be 6 times 2 equals 12. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so what would be my bond order?
They live in this hallway.
1/2 times 8 minus 4, so that's 4 divided by 2 is 2.0. Okay, this one was 1.5, by the way. 2.0, 1.5.
Okay.
Questions on that? Now another thing that you should be able to tell is that here O2 is paramagnetic. How did I know that? How did I know it's paramagnetic? It has unpaired electrons. What about O2 1 minus? It's also paramagnetic because it has unpaired electrons. So that's another question that they might ask, whether it's paramagnetic or diamagnetic. But that's something you're already supposed to know from chapter 8. All right. So we got one last one. O2 1 plus. It's going to be 6 times 2 minus 1 equals 11 electrons. So I'm running out of space, so I'll just write it from the bottom. It's like going downwards like a fucking staircase. 1, 2, 3. 1, 2, 1, 2, 1. Yeah. Oh fuck, where's the thing? Okay, right there. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so it's still paramagnetic, but what is our bond order now? 1/2 times 8 minus 3 equals 5 halves. So that's the highest energy. Does everybody agree with that? That's the highest energy. And then what's the second highest? O2. And then what's the lowest? O2 1 minus. So my answer is A. There we go. A. Good. And then last one just says which one is the most stable? And the most stable should be the highest bond order. So O2 1 plus. All right. Those are the types of things you should be able to answer. Again, once I get the breakdown, I will be more than happy to share it with you. It was really long today. I thank you guys for coming. If you have any questions, I'll be up here. Please try to fill in the feedback forms if you have some time. If you don't have time, I understand. It is a long review. Okay? Have a good day. Be fruitful. Be fruitful. If you have any questions, I'll be up here. You can go out the back door or the side.
Wait, don't use that marinara. Throw it out. Throw that fucking marinara out. It's gross, Sarah. It's probably bad.
is supposed to do. Okay? So ideal solution means it's going to do what it's supposed to do. So if something is ionic, what are ionic things supposed to do? Separate. Is everybody good at that? So that's what it means to be ideal, right? But if it's covalent, what is an ideal solution supposed to do? Stay together. Is everybody get that? So it says ideal just means do what it's supposed to do. All right. So which aqueous solution has the lowest freezing point? So that means we want the highest m times I. Because we want the lowest freezing point, so highest m times I. Now, I know that we don't have the numbers. We don't know what our solute is, so we can't assume any of these numbers. Does everybody agree with that? I don't know what K is. I don't know what I is, Ti is. I don't know what T final is going to be. But all I know is I can find M and I. Does everybody agree with that? So the highest Mi should be the... One of the directions, if you ever make pasta or rice, I make a lot of rice. Okay? Now, Rolt's Law. Oh, man, this one's amazing. I have to be excited, right? You should be excited for it. But this is the idea. This explains the idea of what? Of adding salt to water, right? A lot of the directions, if you ever make pasta or rice, I make a lot of rice, as you can see. But for the most part, Rolt's Law explains vapor pressure, where if you change the mole fraction, you will change the vapor pressure. Now, how do you change the mole fraction? By creating a solution, all right? So let's say we had a tub of water or a pan of water. I don't know what the fuck it's called, but we have a bunch of water, okay? And they tell you, okay, put salt in there. What's the purpose of that? One is because of taste. Two is because it will raise the boiling point, okay? Why will it raise the boiling point? Because the vapor pressure is lowered, okay? Because Rolt's Law is basically vapor pressure lowering, okay? It explains why you lower the vapor pressure, okay? And you lower the vapor pressure to, again, raise the boiling point, okay? Now, another thing that this would also explain is why when you make ice cream, you have to put salt in it, okay? So that it'll freeze at a lower temperature, okay? But the basic explanation I can give you is that Rolt's Law explains what the new vapor pressure is after you change the mole fraction. So here's a simple formula right here. Oh, by the way, everybody look up for a minute. This is the formula in the book. Pressure equals mole fraction of solvent times P circle, pure solvent. I changed it to VP, so you know that we're dealing with vapor pressure. So it's the same one, so if you're like, oh, I'll just memorize the one in the book. Fine, I don't care. All right? But here, vapor pressure is what I use, so just so I know that it's VP. So vapor pressure of the solvent is equal to the mole fraction of the solvent times VP of the pure solvent. Okay? VP of the solvent is the new vapor pressure. Okay? Mole fraction is what happens, right? If you change the mole fraction, you change the solvent. Because a fraction is supposed to be 1 if you have the same moles on top and the same moles on bottom. Do we agree with that? But if you change the moles, that means you change the mole fraction, right? And it becomes less than 1. So generally, the pure is always greater than the new. Because you're going to change it to a lower fraction. Excuse me. Now, the pure solvent is what you're starting with. Sorry, my voice is really scratchy. All right? So, the pure solvent is something that is given to you. So they told you, oh, okay, the vapor pressure of water is 50. Yeah, okay, that's the pure solvent. But if they told you the vapor pressure of water and salt is 40, then that's the new vapor pressure. Does everybody agree with that? So the vapor pressure of water means it's just telling you that's the pure vapor pressure. That's what it started with. Okay? Now, there's going to be times when you have to mix two solutions together in order to get an overall lower vapor pressure. Okay? So sometimes you have to do this thing twice. Okay? So vapor pressure of the solvent equals mole fraction of the solvent times pure vapor pressure of the solvent. Now, if you're given more than one solvent, okay? You're given more than one solvent in the solution, you have to add the new vapor pressures to get the vapor pressure of the solution. Now, this is a common thing, I guess I would say, in like a car. All right, in the car, what is the antifreeze mixture? It's water and ethylene glycol. It's like blue shit in water. No? Okay, nobody changes the car like I do. But for the most part, we mix those two solutions together to get an overall lower vapor pressure, which raises the boiling point. That's what you want in your car, right? You want a high boiling point in your car, or else that shit's gonna overheat. Yes? No? Nobody wants? Okay, everyone wants to overheat shit. That's good. Yeah.
Why would you want to raise the temperature of water when you're adding salt? Would you want it to boil quicker?
No, you raise the boiling point, okay? You would want to raise the boiling point because then you would take more heat to get it to that temperature.
Why would you want to do that?
Because it makes it go faster. It makes the water boil at a higher temperature. So instead of 100, it would be at 101. So there's more heat. The pasta doesn't boil at 100 degrees Celsius. Makes sense? It's water that boils at 100 degrees Celsius. But if your water is now boiling at a higher temperature, there's more heat overall in the solution.
But it takes longer to get to that point.
Yes, it doesn't matter. But it makes it go faster because there's more heat being put in before you lose the water. The whole point is that when you lose water, it doesn't boil anymore. Does that make sense? So you're losing all the water as you go. But you want water when you're cooking something. Why? Because it gives you an even temperature. So that's why a lot of things are done in a water bath. All right? You guys wondering that? Never mind. Okay, so anyways, nobody was looking at me like, what the fuck? What's going on, right? I'm trying to explain it in terms of what you would understand, but we'll see. Okay, so essentially here, okay, when you read these questions, all you're doing is trying to apply Rolt's law, or Raoul, as they would say, but it's Rolt's law. So essentially here, we would say, okay, the vapor pressure of the solvent is equal to mole fraction times the pure, okay? So when you read the questions like this, you'd say at some temperature, the vapor pressure of water is 78 torr, and the vapor pressure of benzene is 63 torr. For a solution that contains 3.5 moles of benzene and 4.5 moles of water, calculate the total pressure of the ideal solution, okay? So here, when you read this question right now, you're going to notice that they told you the vapor pressure of water. So that means that's VP standard of H2O, all right? And then so the vapor pressure of benzene is 63 torr. So that would be VP standard of benzene. You don't know what benzene is, so we'll just write benzene the word, all right? Now, that means when you read the question, you're going to notice that you have two solvents here. Okay? Now, whenever you have two solvents, this is essentially the formula that you're going to follow. Because VP of the solution, okay, VP of the solution is when you add the two new vapor pressures together. Okay? So if you only have one vapor pressure given, then you only have to add one. You have to worry about one. But since you have two, then you should add both of the new ones to get the VP total. So when they say calculate the total pressure of the ideal solution, we're basically going to do VP of solution equals VP of water plus VP of benzene. So now, how do we find the vapor pressure of H2O in the solution? Well, it's supposed to be mole fraction of H2O times VP of H2O. Okay, it's all based on what, folks? It's all based on water, okay, because it is the solvent. Now, a lot of people will say, well, how did you know water was the solvent? How did we know water was the solvent, everyone? Everybody look up. How do you know water was the solvent? The vapor pressure of water is given. So you assume that that's the solvent. So right with that, it's actually two solvents being mixed together. It's fine.